Hello everyone, welcome to all of you in the today's session. Myself Prashant Yadav from the CSC second year. Today I am going to discuss about the tree agenda graph. In the tree agenda graph, there I am covering from the scratch. You did not need any advanced things to know. In this lecture, only things I pre-request for all of you that is the recursion. You have basic knowledge of the recursion, like you have solved the question sum of factorial, Fibonacci series, and the printing of the pattern. The lecture of recursion and backtracking have been taken before, so I hope all of you have watched that lecture before watching this lecture. In this, uh, firstly, what are we going to cover in this discuss? Let's about that. Firstly, about we are going to cover the trees, and after that graphs. In the tree basics, definitions, terminology, types of trees, and different types of traversals. And in same manner, we are also covering two topics in the graph basics, and the different types of traversals. Firstly, we understand what is difference between linear and non-linear data structure. And all the topics that you have, I mean, the data structure especially that you have learned, that are the linear data structures. You have learned arrays, linked list, stack, queues. These are the linear data structure. In the linear data structure, you have able to access only the element in the sequential manner. In the arrays, you only access like you are some index like I, then you only access to I plus one, then go from either front or I mean previous. You go from I to I plus one or I minus one. Uh, in the linked list, you can go from same manner linked list. Maximum possible is a double linked list. Means you can go front or back. In stack, just one direction. I means you can push in the same and also pop from the same. I mean same header in the same manner queue. In meaning only one direction possible. At least means front back. You did not have any other type of direction. But in the tree and graph, this is non-linear distribution. There is a wide variety of the directions possible in there. And trees and graph are the more realistic. Means in the real life problem solving, they are more used. In the graph, you have I hope you have heard about the Dijkstra algorithm that helps us to solve the like Google Map problem, shortest distance between 2 points. These interesting things are included in the graph and many important things in a tree and graph that can solve real life problems. And so this is why important tree and graph to be learned. And in non-linear data structure, there is a formal definition has been given. In the non-linear data structures are those where data elements are not arranged sequentially or linearly. Instead, they are organized in a hierarchical or network-based data structure. Uh, Below, we will discuss what is how they are non-linear. Let's see how they are non-linear. Firstly, we understand from this. Do not go in the terminology. I will discuss. Firstly, see in the arrays and linked list, how means access your element. Firstly, you have index I, then you are going to index I plus one. And if it's I means it did not index is a first or last. Then if you are middle index something like you have element before and after that, then you are able to index maximum element I from I to I plus one, then go below I minus one. But there, see there, you are going from this element to this element and this element to this element. And there is also possibility that there something like this. There is another attached next element. Mean you can go from this to this to this. Let's see image. Uh, Multiple. Uh, there is a going to image. I did not have image of many, but there is a possibility of there should be more childs. Means their attachment such like in arrays the next element attached. Similarly in the trees, this seems to me means its next elements are these are two is its next element, and their attached element means you can go from this to this to this and from there to many directions. This is why seems to be linear. That's why they are called non-linear data structure. And similarly in also graph, uh, let's we are going to discuss about the what's this tree and how this is just appears, what difference is terminology and different things. Firstly, understand how in the trees in the DSA. In the real life trees, leaves are at the top. You are everyone sees the trees, leaves at top and roots at bottom. Like this tree is a normal tree in but in the DSA and in the engineering, this tree is a inverted manner. Roots at the top and the leaves at the bottom. And why? Because the top node is called the root in the trees, and the bottom leaves means these are the bottom leaves. This one, these are the bottom ones. The bottom ones are called the leaves. That's why this is an inverted manner. Means root at top and leaves at bottom. And tree is similar to the family tree. Means just like similar. If your your grandparents, then seems these are your parents, then uncle, auntie, After that, you and your just I mean your siblings on your uncles, daughters, and sons. In the same manner, there is a tree. Like this is your grandfather, and this is your father, and this is your uncle. Then this is you, this is your sister, and this is yours. I mean your uncle's daughter, and this is your uncle's sons, and this is your uncle's sons. This is same manner means family tree. After that, we will discuss its terminology. Means you can understand why tree is called the family tree or different tree word is related to something hierarchy. In the same manner, that's why this is the reason. Let's discuss its formal, I mean formal terminologies. The this one is a root. I have discussed about this. This is root. Root means a top node that is represent entire tree. Means when you are able to you know this root, then you can cover all of know. Means you know all things. These are things. This have store the information of next one. Then next one store next one. Then this one store next one. This store this one, and this store this one. That's why when you know the root, do you know the entire tree. This one is a root. In the English, you have studied about the head, something like head. The head that store the address of next node in single list and address of previous node in the doubling list. I mean first and next both nodes and store the element. I mean there are three informations are stored in the linked list. Firstly, in doubling linked list mainly there is a one part is stored the next address means next element address, another is stored the previous element address, and another is stored data mean what the element. In the same manner in the reach, this is node. This stored the mainly in the trees you can have any number of childs. Means what the child mean that are element derived from that. Means these B and C are the child of A. There could be another child. Means something like D that is attached to. There is a not compulsion of B and C. Means when you are talking about the binary tree, means binary means two. Then there is must. Then you could not have more than two childs. Means you could have one or zero or at max two childs. In the if you someone says trees, then that could have any number of childs. There is just some B. I means yes. Root stores. In this lecture, we are going to mainly focus on the binary trees. That means they are, that have only two childs. The till child, the one child is represented as left, and another child is represented as right. Means left child and right child. To give the name, you could have any other name, but it is a main conventions that everyone adopt. That's why. The root element, any node, any part of node, every it is a single unit of that part of tree. What's the node? Every node in like linked list, there is store three information. First one, like in doubling logic, store the next address. This one store the left address or right, any console, and the previous address that store the left one or right one. Means that parts one store the left one and another store the right one address. And another thing is the key, means data that is stored in that, like this one. There you can easily able to see the first one store data means any node store data, left address and right child address, and its child also same manner store data, left, right means left child address and right child address, similar to that. After that, in what's the parents card? Like in the normal life, parents what any child means consecutive. I means in family tree, the consecutive part of the ages means the D is a child of B, and E is a child of B, and B is a child of A. I hope you got it. This is simple things. After that, I have discussed root, keys, parents, and edges. What is edges? Edges is a link between any two nodes. In linked list you have studied one node is connected to another node that connect to that connect to nodes, that is known as edge. Child, what is child? The anything that is a part derived from its parent. Simple. Child. And siblings, what is sibling? Like just like normal life, you and your sisters and you or your brother, anything that's derived from your parent, that is your sibling. What is subtree? Sub means part of something. That's tree. Subtree mean part of something tree. That's like this one. The only condition you have to note is that the when a tree is all nodes should be connected. Means no one node could be like this. Means if this tree is disconnected, means this is not part of a tree. Let's understand this one is a not of a part of tree, and there is a one node given. This node is given, and this is absent, and this is given. The entire could not you see a single tree. this is different one, this is different one. If you link, then you could say this one is a subtree or tree, anything you could say. And the what is subtree? Anything part. This one, this one, this one means anything that is connected through single one. Mean you can cover all the things through any given nodes. Means its root. There should be any root, and you can able to cover all these nodes. That is a part of a tree. And what's the next topic about is highest leaf. The bottommost nodes are the leaf, means that did not have any type of child. And there is another topic there is not mentioned, that is ancestors. Means like in the normal life in system, in your ancestor is grandparents, grandparents or grandparents, father, anything. The, means it's what its ancestors. Its ancestors all that have a path from its origin to itself, means except that are help in its derivation, means that are going to be in the future, means anything that help in it generation of it, that are its ancestor. Simple in like normal life, mean there is ancestor of k is a b d h, and in the simple manner. And another thing, ancestor like descendants, mean simple, what are descendants of a, that are derived from a, something like all the left tree and right tree, all the childs are derived from a, and that are descendants. Leaf child. What is the height? Right? Height of child is the distance from taken from the any nodes. There is given, and the length of the longest path from node to leaf. I mean longest path from node to leaf. Mean if this is a given, what's the its height? Its height said to be distance from this node to leaf node. And there is another thing, the longest path means this is also leaf G, but there is a given another things, this one. The longest, I mean the height of tree is 1, 2, 3. You could not say one, means it is the longest path from that node to leaf nodes. What is the height of a? This is going to 1, 2, 3, 4. Means number of edges you could say. Number of edges 1, 2, 3, 4. And this path has, I mean 4 nodes. This path has also 4 nodes. So maximum possible 1, 2, 3 also 4 nodes. Maximum possible height, I mean maximum possible length from node to leaf is a 4. The height of tree is a 4. What is the depth of tree? Depth of tree is a maximum length of path from root node to that node. Means what its height? Its height is distance from that node to leaf node, but its depth is from root to that node. Means root to that node means just a single there. And what is a, let's say what is the depth of J? 1, 2, 3. Mean distance, or you can say distance or the path. I mean length, distance from length from A to J. 1, 2, 3. This is a 3 unit from there. That is a simple depth. This is simple terminology. There we are going slow just to understand some basic stuff. After that we are increase some of our speed. There's the basic definition of root. The topmost node of tree which does not have any parent node is called the root node. Means this node did not have any parent above it. You can able to see in this image, did not have any parent. That's why this is a root. Leaf node, the bottommost node, I have already discussed about that. Ancestor of node, I also discussed about what the ancestor of anyone I, then you are A, B, E are the ancestor of the level of node. Yes, one of the most important topic is the level of node. What is the level? Level is a distance from the root. You could say root. Yes. What's distance from root to root? 0. So its level is 0. What's distance from A to B? A to B is a just single unit, means one edge. One edge is one unit representing. Then level 1. This is also single unit away from root node. Then 1. This is 2 unit, means this one, this one. That's why level 2. What's level 3? 1, 2, 3. 3 edges between the root and that node. That's it. You could even say depth of node is a level. Yes, you can say depth of node means the longest path, means single path, only single path exists between root to any node. You can say anything that you understand. Level. I hope you are got about the level. Level is the most important in this terminology, because there are a lot of questions asking about the levels. And the depth of node I will discuss about, the height of node also discuss about this. Let's discuss about the its internal working of tree. Mostly we are going to about binary tree. I already told about that. Binary tree is a simple things, means there is not complexity of much complexity. That's why we are going to binary tree. A binary tree is a tree structure in which each node can have at most two. Already told about that. This only two, means left and right one. Mm, left is to left side, right is to right side. We can discuss about its code, how it is stored in the code. This is going to theoretical step. I can code in local ID. That's how you can able to understand and relate to linked list how it is similar to that. Let's go clear it. In linked list, you have noted something like this. If you are struct something like node int data and node star next node int val data is equal to val and next is equal to null ptr. In list, these things you have been told to either this one or you can in this one also possible in from the classes class node class node after that and declare same things int data node star next and there is a just a simple step initialize the data when next is equal to null ptr or int data is equal to, sorry, you could not have same name, data is equal to val. This is a simple thing you have understand in the linked list how node is stored in the linked list. There is a slight difference in the linked list and the trees. You data is same. In place of next you have different one, that is a, you store node star left comma star right. A slight thing in us initially beginners like you have to asterisk sign on the each variable. Either you can use type def like is systems or you have to attach star to each one. You could not like something like this node star left comma right. This is not correct. Right, this is false. This is not correct. You have to initialize something like this node star left node star right and int val. And I mean the while you are initializing a single node, there is a passing data. What you are assigning the value. There is a value something like 5 or something like 7, anything that is passed there and assigned to this node. After that, you are also analyzing is next means it's neighbors. In the linked list, neighbor is like next or previous in W linked list. There is a different step. There is a left is equal to right is equal to null ptr. Like I am clearing the linked list. Yes, this is how stuff is stored in the trees. This is a very simple. I am telling about this means I am going very slow to everything covered. I means from everything scratch covered. No one feels lagging behind. And another thing is in how you are storing a class in the same manner. Just copy paste there. Okay, I know that this is destructor. You will understand in the OOPS. I hope second semester in OOPS. Yeah, it's a second or third. Yeah, let's skip that. Into data and node star next. This is simple thing. How are you storing every node? After this, I hope everyone got in the how the storing in the internal working internal storing of the node. And there is a given code means if you feel any problem, then you can see and type it. It did not type a copy paste from there. I means you could not copy this is image. That's why given you type even type something that could be better for you. After this I am going to discuss about the tree traversal techniques. Yes, I hope it is clear to everyone. Tree traversal technique. What are tree traversal technique? Tree traversal is not just a tree traversals, unlike another traversals. Means traversals means what? Visiting. How you visit all the nodes. Everything means if there is an example given there, this is given tree. How you traverse everything means if it is set to that print this tree. How could you print? Left, right. How could you go that entire tree is covered by? Then that's there are different methods to cover that. There are basically two methods, DFS and BFS. DFS means depth first search, BFS means breadth first search, or you also know level order traversal. Why the depth first search means why it's said to be depth search. Depth first search means when you are given the road, then you are firstly go in depth means depth of node. When you are going inside that tree, lightest to the leaf, from root to leaf. After that, you are returning. And why the VFS called level order traversal? This is called level order traversal because you are covering to level by. And as above, I discussed what is level? Just root, its child of child, then its child. Similarly, this is going on. This is 11. If you are printing through BFS, then it would print A, B, C, D, E, G, F, H, I, J, similarly that. And if you are DFS, then there are three types of DFS basically. One of these is in-order traversal, and another is a pre-order traversal, and one of the is a post-order traversal. And let's have discuss about that. In-order traversal. In-order traversal. What's the in-order traversal? Basically, in an in-order traversal, you have a special type of convention that you follow. Okay? Means firstly, you have to if you are at any node, let's this road, then you have to go that node's left. After that, right? Sorry, nodes mean that node. After that, right? This is a recursive call. Means let's understand through the code. Um, there, if this has a root, they call for its left. What? Its left. Its left. What is left? This is 2. Its left child is 2. Then again call for 2. Not the print this is 1. Do not consider this 1 as the nodes here. Now it transferred command to next node 2. Then its left child is a 4. And now again no command transfer to 4. But there is a no left child. Then what's the next? Node. Mean process this node. Mean if you have to store or print, that's anything you can do. Next, it's right, but there is a did not any type of right child. Then return from this to parent, or it's 2, again 2. We have already called to 2. And next, we have to process the root, I means process the node. What is 2? Next, it's called right. There is just another child, that is a 5. What we can do? It's called left, it's left, but there is a did not any type of left child. Then process the node 5. Similarly, there is a 5 which is printing here. And then it will call its right, but there it did not any type of right child, then its call stack will return to 2. After that returning to 2, it have called all three, means left, node, and it right. Then it will return to call its parent. Then one will process there. Because why? Left, we have processed the left, its left part. It is a left subtree of 1. Now we'll process 1. When we are printing basically here, then there you can see there is a 1. Next, what we are doing? We are calling for one's right child or subtree. Could anything say? Right child. Right child. What is the right child? Its right child is 3. Then now 3 processing the 3. Processing the 3, but before that we are calling its left child. What's it the left child? Its left child is nothing. Then command return back to again 3. What will process the 3? Then again the printing 3. And next it will call its right child. What is the right child? 6. Then again this same command, means everything on every node you have to run this command on every node. And what we are processing? 6. 6 left child is null. Then again return to 6. Process the 6. Again it's a right child. This similar to one. We will look up its code. Then you will understand more clearly. Mm, yeah. We could now process to ID, so we can solve this question through the code. That will be more clear to your dad. Mm, Nothing else is the same. Now, firstly, we will make a tree. Yeah. How would you initialize and store the tree? We are going to same tree that is given here. So that's why most clear. What is given? This is a 1, 2, 3, 4, 5, 6. I would make this tree. How would node? Why would I took root is just any variable that you take. I had taken root. It concept very familiar, means very frequently used. Then it's remembered. What first is a 1, next is a root's left child. What's root's left child? You can see clearly that root's left. Root means 1. What's your left child? 2. Let's write there 2. Again, you can write on what's root's right child. Right child is clearly shown there. Yeah, right child is once right child 3. I am initially writing a tree. How tree is stored means writing a code. It is a snippet of the means class and object you are understand. That's not exactly, but you can think similarly. And what's is one? Currently we are on 2. What's 2's right child? 2's right child is a 4. Then write it. Roots left, left's right. I hope everyone is getting that. Means it's saying that roots left is what? 2 and 2's right. Sorry, 2's left. 2's left is a 4 and right is a 5. Right is a 5. Next, after that, what's the I means it is completed the left subtree of 1. This one. I have completed till now this thing. Now I have to the once right things. Once. Left subtree root means 1. Once right. What once right? Once right is a 3. Next, once right. Once right of right means 3 is right. Then this thing. What is saying that? It's saying that initially we have initialized the root that is 1, roots left that is 2, roots right. That's saying the roots right. Another thing here, roots left. In the figure you have clearly shown that there is also coding. Yeah, it is very helpful. 1. It said the root node is a 1. Its roots left is 2. Roots right is 3. And another is roots left. Root left. Another thing is root left right. Root left right. That's good. Another thing, root left. Oh, sorry, there is a mistake. It should be right. It is not left. It should be one root right. There is a mistake in my code. There is a good clearly so this is should be look like this one. Roots right. That's it is not left. I hope this is simple things. These are clear that how to initialize that. And similarly, that's you are initializing in the linked list means this is a you can say hard coding. This is not like that in you are getting in the input. But hard coding, you can make on that adding a new node or anything else that you could do. Uh, Next, we are processing the in order. Means after that, storing the nodes, we can process. How are processing the in order nodes? In order nodes, there is a IS. Let code this, then understand it. Ah, it said that we are calling a function, making a function. Because why are making function? We could code inside that means inside the function, but we can use it frequently. Then it makes the dry run principle. I means write once, use again. I did not write again. That's the coding. Then simply in previous class, I thought you have attended that Avinash Tech, in which he well taught about the recursion. Then there is a in the recursion one of most basic thing is the first you write that's a base case. What's its base case? Base case mean if root is null means if anything let you have provided nothing that are null in you are just nothing you have writing like something you have write something node star a but that's it and you passed in order then this is a null means nothing inside it then what's it then nothing print and return means but expose the function that's it but this is the base case. Next, if it is a not null, like our tree, this is clearly showing that this tree not null. Then what we do in order process? I have clearly said that what is in order? First we process left, then node, then right. The same thing we have write in code, just nothing. We are recursively calling for roots left, then process the node. Here we are printing the node. root data. Again, we are calling for roots, right? This is just a simple code and a small code. You can easily understand. Nothing much overwhelming in that. Uh, yeah. This is yeah. Next, it's we can analyze from there. Mm, yeah. In order, call for left tree, print the node, call for right subtree. Nothing in that where's hard concept, just as one. We can you can also solve this question from the given link from the lead code. I hope everyone is doing well. Mm, there's a calling from in order traversal. Okay, I can run it in so can that you can more feel confidence. Oh, sorry. Mm, yeah, you could see that here that why it going wrong? Wait. Mm, just a give me a second. Root not wait. It not. I hope running well. Oh, sorry. I am not calling function. Yeah, you can see that. 425136. Yes, you can see that 425136. Nothing else. You can easily understand. Just to solve this question will be enough. Not much in order to result. Write your go to LeetCode and solve this question. After that you watch video, then you feel concepts more absorbed. Otherwise, it will be lecture slightly maybe tough for late because these are new topics. So that's why solve this question. That would be great for you. Now we are processing to pre-order traversal. If you are understand the in-order traversal, then you can understand to pre-order and post-order very easily. Pre-order traversal. What's the pre-order traversal? In the manner where what are you doing in-order traversal means for every node we are calling its left, then node, then right. But in pre-order traversal, there is a slight change. There is a process. Firstly, we process the node, then it's left, then it's right. Means if this is a tree. Firstly, we process one, then they are counting one, then we will call its left two. Now, same call for two means again we process two, then what? Then two go to its left four. What will it do? Again, it process four, printing four. It will call its left thing null, then again return its right is null, then return. It goes to 2. We have already processed 2 and we have already processed its left. Now we are going to its right. What's its right? Its right is a 5. And what is saying? Node left right. Node, what is node? 5. Its left? No. Its right? Nothing. Then again return to 2. We have completely processed its all three things. Nodes left, right. Again we are back command transfer to again 1. What we have completely called node and its left subtree. Again, we will call its right subtree. It goes to 3. What will process is process the node, then 3. Its left is nothing. Then it will again return to 3. Then it will process to its right. What is its right? Its right is a 6. Again, we process the 6 and its left is a nothing. Means null. It pointing to the null. then again it's right is nothing. Then this again command transfer to there. This is a very, I have said that if you have slight knowledge of the recursion and field concept is small concept like factorials, I means factorial, Fibonacci, these are very basics, and some printing the pattern from the recursion, then that would be very great for you understanding. If you are lacking in the recursion, then both region graph will be like very danger for you means. Let's we have look up its code and how it's stored and anything else. Mhm. Mm. Yeah, sure. In order code, in order code, exactly looking like pre-order. Just a simple difference. I have changed in order to pre-order, and returning condition is the same. Just write means we are initially processing the node first. Then that's it. It is same. Just changing the order of line, nothing else. This will become now pre-order traversal. We call here function pre-order route. Oh, yeah, yes, there need to be changed because I changed the function name. It said 1, 2, 4, 5, 3, 6. It said 1, 2, 4, 5, 3, 6. It's in order. I mean, in pre-order traversal. If you have knowledge of the, I mean, okay, let's skip that. Mm, you have understand the in order and pre-order. There in this concept have same understanding. You have just few lines of code. If you understand in order or pre-order, then understand these DFS would be very easy for you. And in the DFS concept, you have a lot of questions on the DFS concept if you go forwarding about in the topic of DFC. The third topic is our one of the traversal is a post-order traversal. If you understand about the topic, this is will be like cakewalk for you. Post-order traversal. Post-order traversal in the pre-order traversal, what we going to process the node, then left, right. There is just post-order, a simple. We are processing the node in the last. We are firstly process its left subtree, then right subtree, then node. Firstly, visit the root. There are yeah, visit the root. I means visit the node. There could be more sense, or that's also fine. Visit the root means I it there is a term like root not for just only root. This should be node more good. Means you are first to process its left right node. What it left right? Firstly go to its left. Yeah, its left. What one for left we call two. Then again call for two's left. What two's left? Four. We go for four. Then 4 left, nothing. Then 4 left, after 4 left, we should call right. What its right? Its right is also null. Then last is node, means in firstly process roots left, roots right, then node. Then we are clearly so you can there is a 4 printed here. After that, all three things are completed and return back. Then return back, it called the left, now it will call its right. It what its right? Its right is a 5. You can see that the 5 it's a 5, then after that it will call its left. What is left? Its left is a no child means null. Then it will process its right, its right that is also null, then it will print 5. After that it completed its procedure, it will return to 2. Now 2 has completed its left thing and its right thing. Now it need it time to process its on means its node, it printed a 2. Similarly, that it will return back to 1. 1 have processed its left, now it's time to its right subtree. It right subtree call to 3. 3 is left is null, right is a 6. We are come to SIGST. 6 left null, right null, and we process 6. After that, it will return back to 3. 3 have processed its left, process the right, and now it's time to process its on means 3, printing the 3. After that, it will return back to 1. one has processed its left subtree, one has processed the right subtree, it will return back to 1. I means now it's time to process the 1. There is clearly you can show that this is a complete output of this traversal. There is also question given that I means uni-valued binary tree. There is a uni-value by binary tree. It said that question I can see you copy that. Let's go. It's taking internet slow. It will discuss later. Basically, this uni-valued subtree said that you need to just traverse and checking each arc means if, the tree every value. I means key data has same means that tree should be look like 1 1 1 1 1 1 means any value that is the same value means complete tree every node should have same value, then that is a uni-valued binary tree. I hope maybe it return true or yes, that should be means if it is uni-valued tree then you need to return one. I have just you need to carry a variable that store the root node and you can compare all the traversal means you can took any traversal or any of three and checking the is value same for that or not. If anywhere you find not, then you could return from there. I can code it on my local ID, but there is a internet connection not well, so that's why I could not do it. Yeah, let's code that in local ID. Firstly, it we make we firstly check if are this tree. After that, we will check by I means editing the value. After that, what's its name like funk, nothing more. Root. And another thing you can check if root is already null, root is equal to null PTR. Not no, yes, I will check there. Not be complimented. Then the print means if root is already null, then arts value same is same sense. Given in the instruction, you have to it mentioned there. You have to this condition be true or false. Func root bool a and process is root value store its value. Int a is equal to I mean its while is equal to roots data and pass the root data with the func value. What's that? Well, I mean sorry. Yeah, you could take yeah well. After that, if a means if a is equal to true means return the true, then it will print it. Print the basically you could print yes simply else cout no and edit it func and well it could be referenced. Yeah. This is just a reference. Reference means if you change the value inside your inside your function, then it will also change there. Nothing. You could not reference it. Not required much. Um, this is a base condition. If root is returning then it's is true. Means null PTR, that is the same thing. Means if value is different, then there is a problem. Else not. We call it. We have inorder tree. What is inorder tree? Inorder tree will first process its left, then root, then right. Root left, comma while. Oh sorry. Func bool boole. If left subtree return true, then return true for next one. Not need to call its down tree or anything. If you find wait. Okay, you did not need to find. You have to completely search. Then it should it's both means you should have both left, right, and everything should be same value. Oh, then call for left and store in a like bool A. You could say. Next, check for right. Yes, I know to process that, but I can check directly there. Not need to we go extra functions. Right, comma while. After that means everything is true if A and B and node data equal to while, then return true, else return false. It said that if root is null ptr, this is base case. This is a base case. If root is already null ptr, then return true. Another thing, bool a equal to func root left means calling for its left subtree. Means you know eventually you have to traverse entire tree and every node needs to. If any node have different value, that is a false case. Then I check left, right, and another thing is checking current node. Means current node. What mean by current node? Means the node from that you are calling its left or right. Then it is a bool. Means A is a bool. It should be if all three cases are true. Means if left subtree is true, the right subtree is true, and its current node. Means if all the nodes in left subtree, there is a in the graph, all the node in its left subtree. Means if this is one, this is one, this is one, means its left subtree to one, current is one, then it also good. If it one, it would be one, then it will return one to its parent. Else return false. If any of the three cases, it will be false. This would be the simple code for the this answering this. And yeah, you did not need this if you have to more simple that. Yeah, because it's control from inside. Yeah, we are controlling in some base case. After that, we are going to our next topic. In order, we have completed the DFS all three in order, pre-order, and post-order. And there is a question given. Acha, same question. Next is a level order traversal. This is a means breadth first search. What means breadth first search? Breadth first search means level order traversal. What is level order traversal? You can say that there in the with arrow clearly shown. Firstly, we printing processing the 5, after 12, then 13, then 7, then 14, then 2. After that 17 and so on. This on the level clearly shown that 5, 12, 13, 7, so on. Then how would you code this? Means how would you print in this manner or access in this manner anything you needed it? Then in the I hope in lecture 3 there is a concept of the queue and stack linked list or lecture 2. Then there I will tell the data structure queue in the that maintain the order of the FIFO mean first in first out. This concept will help us to cover the DFS means sorry BFS order, maintaining the BFS order. Even you know BFS DFS we could do even BFS with any other miners, but Q is a simple. Then now let's deep dive in the code. How do you code to derive this? Means we could print this pattern. Eventually, our goal is. And then there is a code given, or I could code for better understanding. let's let's go there. We are processing, I mean printing in the BFS order. Uh, Nothing need to return. Void BFS. There should be pass only root need. In main from main function we pass the root. You can even make the functions in inside the main function. I am just not making code much bad, means clean should be more precise for you. Then firstly there could be, yes, you could write base case for this. Means if the null PTR print nothing, because the tree is null means nothing in the tree, then return from main function. I means from just BFS function to main function. Next, what we needed? We need to make a queue. Basically, previously you have used forward queue for storing the int data structure, char data structure, or like primitive data structure. But here is a derived data structure node. Means here we are processing the nodes, not dealing with int or any other. Similarly, you could think it is a container. Int is also a container, node is also container, but we could make int from other container, mean container inside container. We have node is a bigger container that contain nodes, int data, or many things there you could see. So just treat node data like a data type. It is a data type, but it is a derived data type. We derived from previously some basic data types. So and let's name this queue dot push. What's why written that queue when pushing the root means in the queue. Firstly, we process top node means root. Then we have just push in the I means push in the queue. Nothing. And there is a while queue dot empty. Queue dot empty is equal to 0. If queue is empty, it will return true. If queue is a not empty, then it will return false. Then there is a initially means queue is empty. Listen clearly. Queue is empty means if queue is empty, then it will return true. Else it will return false. It should be noted. Then here when queue become empty, it will return 0. Queue dot empty, it will return 0. Then that would be the case to run inside that. But there is a what we have to queue is not empty. Then there is a symbol of the logical not. This is a logical not symbol. Then I use that. Now how to do? In a level, if queue process all the nodes, mean in a level you have store all a single level, then we need to pop it out all the nodes that stored at a time. Then, but there is a problem. I explain that need to. I mean, I explain later. Just to see this there. Uh, Printing currently all the nodes that have queue, we need to move out that. Then we have calculated the size int I is equal to 0, I less than sz, simple. Means store the front, we make a temporary variable to store its front. After that, pop it out also. Means we have already used it, means we have already readed it from upper, I means above. After that, we have processed the code. After that, need to print it. Yeah, print then this node, currently that node you have stored. Mhm. After that, node q dot pop cout temp data. Okay. Just up now, if you are any level, there you could see. If you are at 5, you process 5. What next you need to push? It push to its child. What? Its both child means 12 and 13. Then We will pushing in the queue next 12 and 13. Push in the queue. If triumph left is not null PTR, then push it in the queue. Q dot push. Similarly for its right child. Very good, Sue. Now, why I have taken this one? Why I have taken the size calculated initially? Because you are also pushing in very low there. If you are calculated not, then it will also pass for next level. Why? See there. If I did not calculate size, then 5 will process, after that 12, and 12 child also means 7. You could print this pattern without the loop, means without calculating the size. But this I need to print 5, then there should be a endel, means line break, then we will print 5, 15, 12 and 13, then will this means more better looking code. That's why I calculated the size. If you did not need that, it means if you needed this pattern, means single line pattern, then you could not use size. Simply you could do that. And there after that completing the loop, means this loop, where this is ending, they are, it should be their ending. Yes, after that, after completed loop, you need to give a line break. This one, I think everything is good. But I need to call it control plus C, BFS of root. Mhm. Let's clear that function. Mhm. The q dot empty is not null. You can now see that. Wait, yeah, 1 2 3 4 5 6. Wait, yes, I think this is good for above one. For I have, means our tree is this one. That's why we are need to this one. 1 2 3 4 5 6. This is a, means if you print the level wise, but in the normal coding, I think did not need this. Not did not you need to print like this. But for you did not, you need to know how you accessing the level. There are some things like in some questions you need to access the levels. That's why I use it. If you are, you did not, you need to only print, means accessing the every lines in sequentially also manner, but did not entail, then you could simply remove this loop. I means there. After this word, we are only going to solve the questions. All the theoretical stuff half tree has been already covered. In this section, there is a few questions like height, depth, diameter, and some PHT concept. So first question is our is a height of given tree. This question we are going to solve in the online ID. So open your online ID and go to your questions through the given link. I opened. I hope all of you also opened the question and try to solve it through yourself. If you unable to solve, then see the solution. I hope all of you have been solved the question and at least tried. Then let's solve together. In this question, I will describe that you have to find the maximum depth of the boundary tree. A boundary tree there is a given explanation and description about the question. Given the root of the boundary tree, return its maximum depth. A boundary tree's maximum depth is the number of nodes along the longest path from root to node, from the farthest leaf node. As I described above that, the what is the depth and what is the height related stuff. There is a clearly says that you have to find the only root of the depth of the root. Means depth of root is also known as the depth of tree. Then what you need to do? Then there is a simple step, means you have to calculate the distance from the from root to its farthest leaf. Then there is a farthest leaf, this one is a leaf, this one is a leaf, and this one is a leaf. And let's copy this image. In this image given that you have to find the height of this node, and what would be its height. Its height is the height, maximum distance from leaf. Then this is leaf, this is leaf, this leaf. What is maximum distance? This one? No. This 1 2 means 2, and there is a just only one. You could return also this one. This is also 2, means you had written this one, this one. Eventually you return to maximum. Then how could you do it? It is a simple just two line of recursion. If you notice in the previous codes of the level of node, there that could be also used for calculating the height. Means you go through level by level, and once tree has been exhausted, then that's returned to be level. In this question, we firstly dealing with base case. What's the base case? Its base case is if root is a null PTR, then just return 0. If return 0. After this, we have to check its left and right. Means check this left subtree and right subtree, and that subtree were longest. Its longest depth, means anything you can say its depth, highest depth, return that. Then you have to return max of sorry, calling the function again for its left subtree and right subtree both, root left, and similarly for root right. And you have to also add one for the current node, because when just only single node present, its left subtree is what? 0, right subtree is 0, and current node is a 1. And yes, there is a taken output 3, means consider this is a number. You have to eventually return the number of levels. This is considered as here not 0 level, this is considered as here level 1. Like in arrays, some considered some question given indexing from 1 and indexing from 0, similar to that. Just run it. Yeah, submit it. Yeah, it got submitted perfectly. In this question, nothing much to describe. This is simple given. You can use their 5 test cases and simple test cases. That's why they could not miss. Let's solve another question. This question is about, this is question given there, that about the diameter. Open the question through the given link. This is on the GFG. That's good. Question links are given in the PDF. You can access from there. In this question, you have to find the diameter of bandit. Given a binary tree and the diameter also known as the width, you means you have to find the diameter, and description is given there. Is defined as the number of edges on the longest path between two leaf nodes in the tree. This path may not pass through root. So task is to find the diameter of the tree. Okay, let's first understand how this given. Copy this image and we'll pass here. Oh, paste it here. Yes. Yes. Wait. This question said that you have to find the maximum, I mean maximum diameter, and what's the diameter is given that. Means there could be any node, something like this, and a node's left subtree and node's right subtree maximum sum is, you have to return its maximum diameter. And what's the diameter? Diameter is the distance between its maximum left subtree and right subtree. That and what's this node means, means for which node when we are searching from its left, and which node we are searching for its right. Mainly we are searching for any node, means we there did not focus on this node, means we are only searching for root node. This could be something like this node. Why this node? Let's discuss why could be any nodes. Let's this is root and this is another node. This is another node and this is node. This node contain something like this node. This node contain like only left subtree, something like 1,000 times, and right subtree is also contains something like 1,000 its childs, means it's contain only left childs only, it did not contain right childs, and right child is only contain its right child 1,000 times. So its maximum left depth is what? 1,000, and what's right? That is 1,000. It said that you have to return sum of left plus right. Then what for it? For this node is a 2,000. But what for the root node? Root nodes, its right one is a 1, and for left one you have to return maximum of this. Then you could take this one or this one. Then what's the maximum? 1,000 plus this node. 1,000 plus 1,001. 1,001. What's the maximum? 1,002. But the maximum is a 2,000. That's how you could took any node. Means it is possibility that just not, did not take only root node. That could be any other node. This is the stuff what you need to do, and how do you code. I would solve this through the map, and yes, there maybe question is there is a unique value or not. Let's check it. Uh, this unique value was described. No, there is a did not say, means 1, 2, 3. You could not store in a map. I hope. Yes, STL lecture has been taken already. In this lecture, map is well described. So you watch. I hope everybody watched that lecture. In the STL, there is a map data structure. I mean, data structure STL is a part. You could say data structure for storing key value pairs. You could not use there one as a key, means you could there could be one anything in here, something like there, then key overlap, then you now need to store node as a key. Then what you do, you just do declare a map node star, and another thing something like this, no, just it's some, and yes, and after that go for searching of tree. I means just call it, make a function recursion something like that, root, and pass the mpp, and make the function something like and rec node star root comma declare map. You have to pass map through the reference. That's why you means any changes in it that persist in it. And what's its base case? If root is null ptr, then return 0. And another case, it will be that I will calling for its left subtree and its right subtree. Let's do that. We int a is equal to its left subtree. That will be rect root its left, and another thing is mpp. After that mppb and calling for its right subtree. When you get it, you have to store it. Means for any node, this node store this one. Then you get it and sum it, something like mpp and root is equal to a plus b, and you have to what you have to return is previous, means as I discussed there I said that you are when you are passing to this node, then you have to need to return its maximum of its left plus right, means I said there if there is a 1,000 on left, 1,000 on the right, you have to return 1,000 plus, means you are considering this node also for returning its parent, means if this is parent, this is child, means this is also its descendants, and this is also descendant, you have to consider this one. That's why you have to return its maximum plus 1, means max of left subchild plus right plus 1. This would now you get their map. After the getting the all nodes, it's left right, and you have to return the maximum of it. You have to declare something like end mx is equal to end, I mean 0 0 minimum 0, where it could be. After that run the loop, and extract the maximum one. Mx is equal to max of it dot second after that mx, and just return mx1. I think very syntactically things are okay. Yeah, it's run. Yeah, it's run. It get accepted. Question is simple, just nothing. I mean, it's a simple working of if you understand the previous things, and especially if you have a little bit of knowledge of recursion, then you can easily got it. Nothing much more. Our next question. Let's pass toward the next question. What's the next one? Let's discuss about the searching in the tree. Uh, there's a given a task. Could you search an element in the given tree uh, for as the above discussed algorithm means in order, pre-order, post-order, and another that is a level order traversal. By this, could you find that search in element? In the all the searching algorithms that I above discussed, in order pre-order, I am searching for every one. If route is given, I ask, is there a 5 in that tree? Then I hope everyone tells that yes, 5 in the tree because I am traversing everyone, and I would recall anything, take array, or just when you find the 5, just return bool. Yes, yes, yes. It's written yes, then it return also yes, and break from the tree and return to our main function. Means this is simple stuff. Anyone can do that. Means if I ask for 6, then what you could do, you go there and you are searching. I throw any algorithm. Let's go through in order. What's go? Left one, it's left one. It is no, return from there. Go for this node, it is no, go for right one. In place, in this algorithm, as a in order given, there in place of this is a printing. You have to this just checking means check is root data is equal to our target. No, if root data is not, then further call for its left right. If it is target, then just return in place of void. You could return bool, anything that could means pass to into main function that is feasible for you. This is a simple step, but in the searching algorithm, we could do much better than this. Means what is time complexity? Means you are searching for entire nodes. If there are n nodes, then what for each node takes a 1 unit time. Then for n, it is take big O of n means it's n unit time. But we could do so much better than this. That's the arising the new concept that is a binary search tree. What's the binary search tree? A binary search tree, a special type of binary tree, the follow the BST property. The left subtree of node. There is again some properties of the binary search tree. These properties are applicable for each and every node. Means these properties are the given three. This is also applicable for each and every node. This one, this one, this one, this one. What's saying that left subtree of node contain only node with value less than the node's value. It's saying that if this one is a node given, then it's all the left subtree. All the nodes in left subtree should be less than this. It's 2. It is BST. Means 2. 2 is also less than 6. And if you go for this node, apply property for this node, there is a nothing. That's why if there is a nothing, then that's true. If you go for this node, then it's left side, this is 7, this is also less than 8. That's correct. Means this property is applicable to all of these nodes. And the right subtree of node contain only nodes with value greater than. Means it's saying that if any node is given, then its right subtree, all of the nodes should be greater than. And let's check it. 6 is given and its right is 8. That's the 8 is greater than 6. Then this is a correct. And let's go for this one. There is a nothing. Then by default is correct. And there is also nothing. Then by default is correct. We go for 9. We go for 8. And there is a given 9. That's correct. 9 is greater than 8. Means this property is also applicable for each and every node in this tree. And both left and right subtree must also be a by BST. Means it's saying that if means this property is recursively applicable to arch means is saying that this is for a given node and all the above two properties are applicable for its bottom of node means its childs means these property again repeat for it and repeat again for it, these are applicable to it, then again repeat for it, means is saying that then Binary search tree be something like that. Its left one is less than it and right one is greater than it. Then if I say you search 7 for it, then you need again for go for random. I did not think you need to go randomly like anything. Means you if I ask you for search the 7, you go there 6. It is our target. No, our target is 7. It is 6. It is less. In BST, we know the property that we need to go the its right. Means if it is means our target is greater, then we go the right. If we go the right, then it meets 8. Oh, 8. It is our target. No, it's not our target. Our target is less than. If less, then go left. If we go left, then we go there. We go there and it is our target. Yes, it is our target, and just return from there. This is simple steps that you can do. And if you are using through in order traversal, you going from its left, then it's see there, then it's there. Means you have to searching the entire tree if it is a present. But in BST, it is we are going simply directly to mean each and every node is our in path of our node. Means if we are searching for, then we could not we go 7 in Italy means less method or less number of paths than it. In the BST, you have to maintain this order. And how could you search in the BST? Is this question given? I hope this question would work. Oh, this is article. No question is not given. I put code in my local ID. How would you design this? BST is given. You have just to write how you search an element. Okay. How would I search? Something like bool and is a node given search SEAR search node star our root is given and another thing our target is something like in data is given directly means you there is a node just like data is given if root is null ptr. Yes, if root is null ptr, what we need to return there? Are you able to think? We need to return 0. Why 0? Let's go there. If I will ask for something like 3, then you go there. It is not, no. 3 is less than 6, then go far left. If we go far left, then we are 2. Oh, 2. 2 is not 2 is 3. No, 2 is not 3. 2 our target is greater than, then go far is right. If not, nothing. If any time we found null PTR means we are our path is disturbed. Mean only one path exists. There is something not like if we did not find there, go far any other. They are nothing like that. We are going in our direction means our correct direction. If direction is something is missing in the direction, it means our goal is missing from there. That's why you need to return 0. uh, yes sir, return 0. After that, uh, check for current node. If current data is matched with our target data, then just return 1. Else what we return, we call recursive call is left and right one. Return right. Search root left data, and another thing is uh, yes sorry, we are not randomly searching, we need to compare. Sorry, if root data matches, if data is less than, if root data is less than data means the data is given, that means our this data is target. Sorry, need to change, there could not be any confusion. Target, if our target is greater, then search for right one. Return search root, oh, sorry, root right comma our target. Another thing I can do is search for left one means only one case remaining. Then you could use else or not use, because in the if function if return it did not go is means it not come out from the loop if it's the given condition is correct. So just return search root left and target. Wait, target This is a good simple one. What's saying that if route is correct means if our path is not complete or anything is missing, they just return zero. Else, if a target is found mean target is logged, they just return means true condition, true from there. And after that, if a target is greater, mean our target is greater than current node, we go for it, right? Else we go for its left, means it's recursively calling for it. That's a simple code. After this, have any other questions? Yes, BST illustration is given that there are simple things to understand. How would you search in this BST? When you are 8, it is 6? No. 6 is less than 8. Go for left. 3. 3 is our target. No, our target is 6. Then our target is greater than. When it's greater than, go for right. When it's less than, go for left one. And from 3, our target is greater, go for right. Is target locked, return from there. This is a just arrow things they given there. Go for it is our non-target, as I discussed that same things. Now we have covered entire tree topic. After that, we need to discuss about the trees. Welcome to the second part of the today's session. That's the graph. In this session, we will cover the introduction and types of the graph, representation, DFS, BFS, and after that we will solve some few questions. Then the shortest path in the unweighted graph, and after that the Dijkstra algorithm. Uh, let's start the session. Firstly, what's the graph? Like tree. Sorry for a little bit of distraction. Uh, a graph is a non-linear data structure consisting of the vertices and edges. Like a tree, graph also a non-linear data structure, and it also same contain nodes and tree. But there is a difference. In the graph, you can access a randomized system. I means there is a did not like tree. Means the when just a two tree from directed from parent to root. There is a did not system exist like the parent and root. There everything is a connected. This is a more realistic than the tree. Means this is in the real life more situational or maybe it is a favorable conditions. Like in the Uber conditions, this is a, in Uber, Ola or any when they are connected and need to go from one place to other place and then they go from one place to another place. It is does not from I means you go from Patna to NIT Patna means junction, then it does not defines means other to directed, but in graph in real life you can go from one to others. In similarly their graph is also same. Node and vertices, it is same thing as like tree and edges. The connection between any two nodes is node edges as like previous in tree. Types of graph, the directed and undirected graph. What's the directed graph? Let's discuss below. But a little bit introduction is directed. Directed means direction. It's have a direction from one node to another node. Means like 3 to 1 and 1 to 3. Cyclic and cyclic means there have some cyclic like this one. Um, this there it is a cycle 1 2 3 1 2 4 3. And a cyclic graph, there is a not cyclic. I mean, if I take 5 and 3 only, or 5, 3, 1 only, or 5, 3, 1, 2 only, means just as a simple thing like cyclic and cyclic, connected and disconnected. Yes, connected and disconnected. As like a tree mentioned, trees should not be connected. I means it all tree nodes should be connected. It cannot be disconnected like tree. But in tree, there also a component exists there also. Let's wait just. Uh, uh, like this. Assume that did not go for this. Let's this is 1 2 3 1 2 0 and let's discuss this is written something else 3 4 5. But if written they are differently, but this is also also a tree means they are different. I can make there like this one. This is assume 9. This is 10. There is a three part. I means a graph is covered all of threes. Means in a when a graph sent it is also different from the main graph. Means it is not any is between this graph and this graph, but it is overall a single graph. It is said to be component. Means graph component. A complete disconnected part is known as single component. Means this is a component, this is a component, and this one is also component. So overall three component there. Though this is the concept of connected and disconnected graph and the weighted graph. What the weighted graph? Weighted graph means there is previously we all discussed the single. I means all the edges have same weight. Same what said to be weight significance of weight means let's say we go from junction Patna junction to NIT Patna. What's the distance? I means distance significance or anything cost or anything you can take. Mean what's the taxi fare? means let's have H20, then it is differ from other places, but it symbolize a single line. How come a difference between them? Then the concept of the weighted introduces, means let's you go from Patna Junction to Beta or something like NIT Patna. Then they have different fare from same thing. Let's assume one is a Beta and second is a NIT Patna. Then the cost from both places is a different one. Then how to represent? This is known as the concept of the weighting. There is a different weight. Let's have 100 rupees for the Beta and the 50 rupees for Patna. Then this is a distinction. We cannot define from length of the line. This could be very informative, not as well. So that the concept of the weighting introduces them. Next, how the graph representation in the coding. The first is the adjacency of matrix. The second one is adjacency of list. How they are differ from is that let's have a look up. This one, this above two are this about two are the adjacency matrix. What is matrix? Matrix is already I studied about that 2D matrices, and the list is a simple like a vector in a C++ and array list in a Java. Matrix is a simple 2D 2D uses there. 2D matrix, how to use it? Let's have this graph. 1 is connected to 2, 2 is connected to 0, and this is a directed graph. You can see there is a pointer rotated. I means arrow there. The one is connected to, and if we said that is one's neighbor 2 or 2's neighbor 1, it only said that 2 is the neighbor of 1, but 1 is not neighbor of 2. Means the node that connects to others node, it's said to be who connects, that is the only neighbor. It is not you can say that 2 is the neighbor of, 1 is neighbor of 2. One can say 1 is neighbor of 0, but it cannot use to opposite manner. But if it's undirected graph like this, then you could say 1 is neighbor 2 and 2 is neighbor of 1. This is simple, means this is a directed graph, this is an undirected graph. How to represent? If 1 is connected to 2, then there is a matrix of 3 cross 3 matrix has assumed, then 0, and means 0th row and 0th column represent when 0 is connected to 0. It is useless to sense that in directed graph it did not any mark there, you assume 0 there. The all unfilled are the 0 here. 1 is connected to 2, then 1 comma 2. Where is a 1 comma 2? This is 1 comma 2. So there is a marked as 1, means there is a direct link between them. And another is a 0 to 2 to 0. 2 to 0, this one means second row and 0th column. This is taken to be 1 because they are directly connected. And which is row, which is column? The node that rows goes from there, that is a row, and the node where reach, that is a column. 2 is a row and 0 is a column. Similarly for 1 and comma 0, 1 is directed to 0, then 1 is row and 0 is column, this one. After that, undirected graph. In undirected graph, there is a little difference that when a node is connected, then you need to represent it is like double directed, mean 1 to 2, one row, and another row is from 2 to 1. Then if connect means you can go from 1 to 2 and 2 to 1. Then how to represent that? Then 1 comma 2. Means row 1, column 2, row 1, column 2. This one should be 1. And opposite manner also, row 2 and column 1. This one also should be 1. Similarly for others, means 0 to 2 and 2 to 0. 0 comma 2, 0 comma 2 this one, and 2 comma 0 this one. This is also 1. And another thing is a 1 0, 1 0 and 0 1. This thing is a connected there. So this is for the adjacency matrix. Mean there you made means if there is a n nodes, you make n cross n matrix. If you are taken convention from, there is taken convention from 0. If you are taken convention from 1, then you have to adjust matrix a little bit more, means you have n plus 1. You have to make a matrix of n plus 1 cross n plus 1, and this row and this column become useless for you. Next is adjacency matrix. You have seen there is a much means garbage place, nothing uses. If it is not connected, then why do we need extract space? And if we have 1e5 or 1e5 into 1e5 wide matrix, then how useless things are. There should be only one connection, but it is a on loads are different. 1e5 only 2 nodes are connected, but we have to represent this. Then why it is too much use of memory, that is not good for us. Then another topic is introducing the adjacency list. How it connected? It make an array of linked list or array of list or array of vector, that you could say. Basically concept is the same, little bit in time, writing of code. Array of list means you make firstly you make an array. Wait a bit. You make an array and each length of the array, and the length of the array is the number of the node in it. Firstly, let 0, 1, 2. It is sequential manner. As 0 you are taken convention or not, start from there. It depends. Then they are attached every to linked. Mean 1 is connected to which nodes? Means if 1 is connected to 5, then write 5 there. If 1 is connected to 4, then write 4 there. If 1 is connected to 2, then write 2 there. And no need of extra space. Similarly for 2, let's 2 is connected to only 9. Then you write 9 there. And when 3, then 3 just write, no, did not connect it to another. It is simple means, I mean, is a single component. Then you have so a lot of space. How? If you have to make, let's its maximum element 9. So how many elements? 0 to 9. There is a 10. 10 cross 10 matrix you need. You need it 100 into 4. 100 into 4 means 100 into 4. Yeah, means 4 int. If you use int, then 4, and then 4 for byte. Next, but here what's happened? Just you need a single matrix of 10, means 10 into 4 plus how many edges are there? What means edges? Mean a single edge represent a single connection between any two nodes. There, if I need to represent this one, how many nodes are useless there? Let's assume for this one, 1, 2, 3. 3 are in directed graph. They're slightly more connected, so that there is not much use. I mean garbage space. But in graph legend, all are different. Then what's needed? There is needed just make a single matrix of 3. That is a 4 cross 3, just 12 bits. But here is what 9 into 4, 36 bits. You can see the difference. There is a huge difference. And in a matrix of 1e5 or 1e6, that could be very large. So this is the manner how can show the space. And similarly in directed or undirected graph. Yes, if you find how you means in adjacency list directed and undirected graph. Let's elaborate this. If you have a matrix in which are connected, let's make it. Let's this. How to connect it? Let is given, then you are given like a matrix input given 1 to 2 and then 1 to 3, then 2 to 3. If your input is 2 comma 3, then you go let main matrix is adjoint, then adjoint of 2 dot push by 3. And similarly for this one, adjoint, there you write adjoint of 3 dot push by 2. I can write more visually on the our local ID. There is a little bit I like writing on this platform. That's why. Let's you are given input is a 2 comma 3 and another is a 4 comma 5. How can write adjoint of 4 dot push by 5, and another thing is a adjoint of 5 dot push by 4. If 4 comma if a connection given between, given that 4 is connected to 5, means in undirected graph 5 is also connected to 4. Similarly, means if you this is basically a directive list is a more directive manner of coding, means it is more used or significance that it is a directed. Means if adjoint, if 4 is a means if some list is stored in the fourth, I means array of 4, then that means 4 is connected to 5. You can assume the opposite manner, but it is a more used in means directive manner. Why? Let's see this. Let you have for each loop. Then how you traverse that? You cannot go in the list and search there. There is another element connected to opposite manner. That you could do, but that is not time efficient. That's why this use more for directive manner. You can convert undirected graph to directed graph. How? Let 4 is connected to 5. Then you can let's 2 take it like there. 4 is connected to 5 and 5 is connected to 4. That is more used in the upcoming questions. It is now I think sufficient for directed and undirected graph and both matrix and list. How to store the graph? Let's see on the ID. Let's clear this. Let's there given is n number of nodes. Then we take input of n nodes. After that, there is a m number of edges. What is it? Edges is just connection between any two nodes. After this, there is now m number of edges. How m edges? Let's have 5 edges, and there is a 5 edges. Some component. Let's have 4. Means 4 edges between them. One is connected between 1 and 4. One is between 1 and 4. Another is between 2 and 5. Another is 1 and 3. Another is 2 and let's have 4. Then this is the given. Then how would you store this? How would you store this? This is basically input, nothing to overwhelming this. N number of nodes, m number of. Now you are every time get 2 input, a comma b. How to store? Now run loop for m times. I equal to 0, I less than m, I plus plus. Anything for loop, while loop, add you adopt. Now how? Wait, you have to make a matrix that could store us. I mean store the edges. Let make matrix a vector of int adjoint of m. I assume that it start from 0. Um, but a little mistake happened, I think. No, it's not worry. I think yeah, 0 could be there, 0 could not be there. That would separate, not issue. And then C in u comma v, u v declare inside there, could nothing. And lets it have undirected graph. How make it directed graph? Then in direction graph, you push from u to v and v to u both. Adjoint u dot push back, and another thing adjoint of v dot push back. This is thing. Means you make a connection from u to v and v to u, but whenever is a directed graph, then you could not include this line. Means usually given first node is connected to another. It is most conventional things. Means one is directed to 4. If it is a directed graph, then you could not include this one. This is how storing the graph happens. Sometimes you may get did not list, or you could get I means something like 2D matrix, not list. मतलब adjacency matrix. How could they could go there? Simple like adjoint of adjoint and adjoint n cross n. Fill. You can easily run the loop and fill all the element in with 0. Let's assume all the element 0. Means all the element of its are 0. Next, after that, we have to learn m times of loop. There is not this loop now because we are making matrix. Oops, above code is same, means n comma m, n is a node and m is for and I is equal to 0, I less than m, I plus plus. Similarly, take the input int u comma v cn and adjoint u v is true. True, or you can write one in C or C++. It's considered to be same. It is true. Means you make a 2D matrix, and when connected to u comma v, it is a directed graph. Means you are singly linked. You assume that u is directed to v. Means you starting from it start from u and comes to end at v. Then it's only one. Means when you go to there 1 comma 4, row 1 column 4, that's 1. There is a row 1 column 4. This could be 6 more better because you are taken the 5. Means there you could not include 0. Means there could be it start from 1, start n minus 1. That is simple. U comma v, yeah, for 2 comma 5. If 2 comma 5 start from, means you go second row and fifth column, that marked as 1. And similarly for 1 comma 3, 2 comma 4, 2 comma 4, yeah. And for undirected from, just you include a single line more, adjoint v u, that's true. That's it. This is now store. Means 1 comma 4 and 4 comma 1 both. I means both both grids should be 1 true and others are 0. As you adopt the this could be feel easy. I means if you write some few codes and print that is good for you. Now we move for next topic. I means it is all the clear. Method of adjacency matrix. This about both codes are given. You can see this. And could you find a space needed for each story graph? Yeah, I was mentioned that how each space are going or space is taking there. This is the same question there too. And there is a question link given this. Then this is same to write some. There you need to write. I means their input given in form of u comma b as I mentioned below, and you need to adjust in form of list or matrix and return to that. You can go and solve this. This is a good question. I mean for practice and initialization it is very good. Now representation how space takes e comma v. E is a shared that there is a number of edges and v is a number of nodes. Let's have a elaboration a little bit. Let's have it only two nodes, means 0, 1, 2. Then it is a number of nodes. You have to make a single matrix that is a length of the number of edges. Sorry, I means nodes. Yeah, nodes. Nodes, or you can see the vertices. That's so that it is a V, means you must have the space of number of I mean nodes. Yeah, nodes. There is number of the edges. How is edges? Let have two edges. Then you include one there and let have it is a one there. Means one is connected to two and one is connected and two is connected to zero. Sorry, this one is a one is connected to two and let's two connected to one. uh, okay, 2 is connected to 1, and there is a new matrix that would be good, more and clear. 0, 1, and 2. This 0, 0, we make a list, and that is not connected to any other. This is null. Now 2, 2 is connected to 1, and there is a 1, 1 is connected to 2. Then how much space? This is V. Means the number of nodes you store, this is a V, and number of edges, there have only 2 edges. Means this graph is more look like this. You have like this, 1, 0, 2. It is said to be like something this. You can a single line undirected. I have directed. I means I elaborate like it directed graph. This is also correct. Uh, then what happens? You need to store every node. Then number of nodes is let n. There n, and number of edges, 1 is 2 edge. Then n plus e, and n for nodes are vertices, same thing. Then there is n is symbolized with v, and e for edges. Then it should be clear. I mean this not more than that. And there is a for adjacency list. Let's say you are there in the above graph. See there. They said the number of v square. V is number of nodes. Then how many nodes? 1, 2, 3 means 3 square. That would be there 9. In this graph, you can see that 1, 2, 3, 4, 5, 6, 7, 8, 9. I mean 3 cross 3 matrix, that is 9. Yeah. Then you can easily see the how much space and how much. Uh, I mean so. Uh, where yeah, checking edges between V and W. Check. I mean if you are given a matrix, and it is said that you need to tell there is a connection between 0 and 2 or not. In how much time you could tell? In matrix, you could tell in big O of 1, when you can directly go to second row and you are go like adjoint or array of 1 comma 2 or 2 comma I mean if undirected graphs in both direction, but it is directed, then adjoint of 1 comma 2 is true. Let's it do A. If A is true, then yes, it is connected. Then mean it you could tell in big O of 1. That's big O of 1. And now another thing is there mentioned. Yes, in adjoint matrix, you can tool big O of 1. And what happen in adjacency list? Let this one adjacency list. You need to tell is 1 is connected to 2 or not. You go to 1. I means in array, you go to 1. After that, you checking its list, means the list that connected to it there. Where is a I means 2. You could not include anything. You could not even think about the binary search there, because that it could be random. I means 1, 2 is first, 0 is first. I means you could not go like anything. You could uh, means you usually did not use linked list. You basically use like array list or any means vector in C++. That is a more helpful, because you could not jump directly. That is a not I means good for you. But it is for most initialization topic. Behind the scene, linked list is work, but nothing. Next, iterate over the edges incident on the V. It said that it said that how many vertices are it let 2 is connected to 3. Then how many are vertices are incident on the 0. Then there said that the number of E. You could imagine that means if how many nodes are connected to 0, you can go 0 and count how many is 2. But there you go, let's it have length of 1e5, let 1e5, 1e5, then you go to 1e5. Let's have last place is already collected, but you need to traverse complete 1e5 length. So this is a more complement, I mean more space taking. If you now got it, then it could be simple. Let this is not connected, but you must need to traverse till last. How you would know this is connected, not connected? You could not unstore anything or any other algorithm exist for this. But in this, you count only number, means the number of the edges or that node connected to particular node that could be counted directly. So E is the number of edges, mean how many node connected to that node is an edges, and V is the number of total, I mean total nodes. That is a V here considered. Now, VFS of graph means traversal of graph. It's like tree, linked list. We have covered a lot of, I mean, traversing algorithm. Now, how the BFS of algorithm works? I mean, you could know the VFS of algorithm, BFS of, but there is a little bit more informative and that can more useful for you. That how could BFS for you? Let's wait. I copy it or somehow thing niche something given below, not there. Mm, I copied it. I copy it. Yes. Let yeah. Let you hot is you said that to one is given and BFS. In BFS in the previous line you go level wise. Let's it is one is tree and something is something like this. This. Then what? Let's it is a root and it is yeah, let it is a root. Then how you go the BFS? 1, 0, 2. Similarly, in the graph, same happens. But how happens? It goes like the let it is a source. There it is not a concept and exist like the I mean so in a tree root like concept. Then uh, yes 1 2. Then this is a source. Then how is it goes like BFS traversal? It goes unit distance. Mean if a distance directly mine direct you could consider unit distance is directly connected as here. Abhi, now think about that left one to connected. How is the BFS? BFS is a one unit distance, means that are directly connected. Firstly, cover is directly connected nodes. All the nodes are that is are directly connected. I can make some few more nodes. Right, Control C, connect them. Just a bit, little bit, wait. And I also connected. Let this is connected, not pretty. Anyhow, let this is source means you need to DFS. I mean BFS start from there. You need to somehow start from there. In tree there is a root given, but there is something like source exist. Means anything that could be source in the graph. Then how would BFS look like? Then in first BFS means in the first level could be say yes level is exist in also the graph. Then it cover these nodes one this one means these are directly connected. After the in second traversal what could be? That are you two distances away from this means one is this one and another is this one. This is second is this one and second is this mean it connect this one and this one. After that it cover second one and this one. This is not connected so they do not traverse. Then what would it look like? I can number them. uh, let it is a 3, it is a 4, it is 5, it is 6, and it is 7. Then if I say, then print the BFS ordering, then how would you say? Firstly, one is a source, then that shows you 1. After that, you need to print 0, 2, and 3 because they are directly connected to this. After that, directly connected means that node are connected to 1 and nodes that are connected to its one. I means its child could say you are that they are directly connected to connected. You can say means that are connected to basically 0, 2, or 3. Then 0, 0, 0 to connected to 7 and 2. What's 2 next? Next 2 is connected to 0. But you need to remember there is a special concept on the visiting array means you could not again print 0. I will tell later. I mean if you know the traverse then could not be again traverse. This is simple. 0 to and 2. Then there is nothing like 2 next exist. For 3, 3 exists 4. In again level, and then you need to present the node that are connected to 7 and 4. What are connected? 7 nothing means 7 node and 4 is connected to 5. In next level you need to do not print anything because it's point to null. 5 and 5 it reduction. This is the BFS ordering if 1 is considered to be source. Oh, 1 0 2 3 7 null 4 null null 5 null null 6. This is the final ordering and last ordering there are layer traverse and all become nulls. This is a simple BFS ordering. I think it is clear. Hmm. Now yeah we can code it for more better understanding. um yes DFS BFS yes we now it code it for the you can adjust I mean understand more better. Void BFS. I mean there is a did not like any concept of the tree means you pointer there is a only uses the array and list. list for storing, but it appears to be in the graphs. It is like pointers, but did not anything like that. This I taken the array of list. After that, I think no need to more than that. This information is enough for the printing the BFS. You will take a queue and yeah, source from where you are printing. Yeah, that is useful. No dot push. Slight more thing there is a concept of the widgeting array. Let I explain. Yeah, widgeting array. Why we would need widgeting another type of array in it? See there, a graph could be like uh, this 102. My means undirected graph. Oh, undirected graph. Then you go from 1 to 2 and 1 to 0, but again it's connected to 1. But how you know one is traversed? Then you need to remember one is traversed. That's for the reason we need to use the visiting array. You can use visiting array or map for the remembering. Anything means you need to just anything store there. This is traversed. In trees you did not know to initial because there could not exist any topping like that. You can move from one means there cyclic things did not, so that we did not need there, but there is a need. We declare array of a number of nodes length, and that's all the files mean nothing is a traverse now. And we push the source. If we are push the source mean we are traverse, then we need to declare which state of src is true, means we know src is traversed. After that simply as like bfs of reverse traversals mean tree, you need to declare a while loop and simple stuff. Q dot empty means until q is not empty means something is init, then run the loop. And you can VFS ordering as like I previous. If you need to print line by line, if some positions that key, that means you need to return a graph is given and you need to return all the its levels, or BFS ordering means sequentially means who are distance one from again two from separately. Then you need for loop for system. Initially I explain means just ordering how BFS ordering. After that we are printing the level wise. Just taking front node and popping it out. Auto is a simple keyword that uses for auto detection of data type. Nothing like more enhansive. This is simple concept. And traverse it adjoint of node. If it nodes, and what are I doing? I am traversing neighbors of this node, neighbors of node. The neighbors of node means adjoint of, we are traversing the list. We are a single array, and there we need to traverse its list. Now adjoint of list as a list. It is a list means when you pass the array of one, there is a connected list. Then there is a list. We are now traversing to that list. If the element that in the list is already not traversed, then visited it is not equal to 0. I means if equal to 0, sorry, means that is a not traverse. Then mark it as a visited. Visited it means it is traversed and push in the queue. This is simple stuff. I think that's the ordering. Yes, so yes, it is okay. Yes, into node, I have taken the node. I think let's add some comment for more better understanding. Completed learning. Complete done it. Now let's check it for its correctness. We need to take some input. Let's copy input from anywhere. Is anywhere input are given or not? It will be a little complicated if not given there. Let's write a simple input. Yeah, there is a link list. No, now not opening. Yeah, I will take the simple one because this input writing is a bit tiresome. I could take this one. but writing is a more this one I think I will take 1 is pointing to 0. I think I write it some input. Let's check it. Creating, yeah, I have already created some wish creating an undirected, but I need to wait just let's write the input. I'm not able to find it. Yeah, let array take of 4. I need to make it. That's why I completely visualize this. It's just otherwise it's going to be wrong. I take this one, not 1 comma 2. I think it is enough. You can take example and apply this algorithm. It works. That means if you I will took three nodes and 3 edges and 1 is 2. Okay, input is taking is 3 edges 3 and 1 is connected to 2, and next what is 1 is connected to 2 and 2 is 0 and 1 is 0. 1 is 0 and 2 is 0. This is input. This is nothing like inputting I am through TXT files. Not too much more than inputting everything. I need to cut it. Yes, input is given and I am taking it out. Taking it out. It is I need to correct it. I means what I am taking as output means if node is not. Oh, simply I print there. I not need to anything. See out node. Yes, run this. Oh, input. What is an oh sorry adjoint of dot. I need to pass there and catch it up. In Java, sorry, in C++, its side is not passed in for the arrays. You can take the from size of operator, but I pass. That would be more easy for me. BFS. Yeah, we need to print it. Note this there. After that, we need to pass and size and size. That is true. The code. This is the taking the matrix input, but I using the I mean adjacency list. Then it need to be improved. Vector of int. After that, input where input taking type is different there. I mean it is not a matrix. Adjoint dot pushback. Simple. I taking directed graph and call for BFS. What is BFS? BFS adjoint, and another thing is that is a source and source. Let's talk source one and a size and passing there from upper variable. That's good. Oh, sorry. It should be equal to 0 means q dot empty means q is empty and not empty, then it will return I mean when it is a not empty, then will return 0. That's two conditions though inside the loop it running. Yeah, we need to print that. We run the loop. Yes, clearly this is the output. Yeah, a little bit system error. 1 2 0. Now I have completed it. Now we are moving to next thing. Mm, There is a high empty, something like should be empty more comfortable. I it not working empty 0. If empty 0, it returns 0. That should be 1. Then it should be current. Why not working? Yes, it works. It's like any other error. I thought this. It means q dot empty. If is empty, then returns 0. I mean not sorry. Q dot empty. When it is not empty, means when it is not empty, then it returns 0. And q dot empty, then it returns 1. Not opposite mean. I little bit it is confusing. Is I means use you can use size if anything is a problem in it. Next thing is VFS. We have completed the VFS, and you can read their statement. I mean yes, I need to cover this. Control plus C. How ordering happens there. go there and paste it here. We have taken 1 to 0 and take it source size of 1. How? This is a 1, then there is a printing 1, and this is a 2 comma 0. We can period also level ordering. This is a simple ordering of, I means level ordering. This is also known as level ordering. Means I know to, I know, I try to say that if ordering is distance happens on the distance, then how could do you that? This is just return, needs need of a size as z q dot size, where this loop ends, check it, and this after that a line break. Let's print it. Oh, 1 to 0. I it not printing the flexes and checking the brackets. Oh, it's outside the loop. Yes, means let's copy it from there and check it. It is correct. You can. Oh, sorry, double printing. Nothing to worry. Yes, you guys see there. Firstly, I print 1, then 2, 0, comma 2 or 1, comma 0. Anything you could say, but they are on the same level eventually. Some question you encounter that there is a source node given and you need to print a 2D, return a 2D array. Means firstly, you in the first means the first row should represent its first level, means self node could be or mentioned in the question. It need to be node self mentioned or not. Then first level it's directly connected. Then second one, then the node that are connected to its connected nodes. Similarly, that goes on that. This would useful. I need there. I passed the indel in same here. You need to upper pass a single array above and the push all the input in it. Let I see the code. Yeah, in it there you need to declare a size means int. Declare a vector int q. Sorry, a temp, and the node that you are printing this push in the temp dot push back. That's like node. Another thing in the last that you are backslash n there means you are completely traversed a single level, then that level should be pushed in the main array, means you are 2D array, there you are found, there you found a 1D array, so you need to push in 10 2D array. Let you make an answer as 2D array 2D dot push back this temp, and above you make 2D array declared anywhere, means above is vector int, it's vector of vector because it is 2D. After that it is answer, it's n rows. That's it, the end rows, and you need to end rows. Yeah, no, did not. That's just a 2D array. You pushing one by one that create automatic space, and you not hide that not any sense of n. Yes, this is the way you can print n by n and return 2D array from your if lash in return answer. This could be a good question, like medium level question on the lead code. After that, we are moving to another concept. It is completely, I think I have elaborated everything well. Store the graph, representation is completed, BFS is completed. And this is the given the question. You could solve this traversals, and if you are not able to solve, see the some. There could be comments, submissions, or you could see this solution and work it on this question. Takes your time. It could be little 30 minutes, 45 minutes. It could be more than that, but takes your time. Now we are moving to next topic, the DFS of graph. As like trees, we are moving BFS mines, BFS, DFS. Similarly, in graphs, DFS concept exists. In the what is the main difference between BFS and DFS? BFS ordering means firstly they order their first neighbors, then second neighbors, this like. But in DFS goes on the one node, then one node means if it is like, wait, I need to take pointer. Let like it is connected to this node, this is connected to this node, and somehow this is connected to this one, and this is connected to this one, and these both are connected, and these is connected. Then let DFS happens. What happened DFS? Let you want traverse from there to there, then there, then there, then could be there. This happens. But in BFS, if actually test this one, if you directly connected for this one, then after connected these two. This is the difference. Means you need to know these properties. How happens? These are useful in many properties when you encounter many problem. Like one of the initial problem in like graphs, like roten problem. In there is a graph given, and if a graph given and there is a some roten oranges indexes given, like presented by 1 or 0, then how in how much time all are become the roten, means you need to ordering like this BFS ordering, then you could know how it happens. Now, how it happens in DFS? DFS simple, means if graphically I could tell, this is simple. This I thought this means this could be go there, this could be firstly go there, this. I means it go first neighbors, then its neighbors some neighbors, which it could be there also graph, then it could be there go there. It depends on the how inputting. Uh, Simply from code you can look it there. It is not much complicated like BFS. Initially, BFS feels more complicated, but you after some time you write some codes, 10 to 15 codes, then that would be very easy, more comfortable. Anything. DFS of graph. Firstly, what you do? Let's call the adjoint and vector of visited current. Current. What is current? Current you node passed. I mean initially you node called. For which node currently it is. Like initially I considered a source. Let is considered as initially it is passed from the main function source and a visited array from the main function. This is the referencing function. What is the referencing function? In the C++, this is a reference, not like addressing. You could know in C++, in C, there is a more address. It is a reference function. Means if you change any array from this, then in the accessing after that array means if in any stage if I change this visited array and its grid, then it if I access from main function or this function after the editing, then it is edited everywhere. Means in the if I go in the stack, then if returning from stack, it also again means after the editing it, if returning from stack, then it also become edited. Means it does not look like previous one. This is the main difference. I need to remember. It means if you need to somehow, if I somehow means covered a node, let it as example, let go there. If I somehow covered this node, we need to and there covered this node, we again come there. We, means this node and this node is not going anywhere. Then again we returning back. I marked as this one, and this node goes there. Let a single node also connected to this. Yeah, there could be a node from 0 to 2. It is not parallelized. I means parallelized nothing means if you connected to 2 to 0, again a node connected to 2 0, that is a parallelized. That is a different topic. 0 to 2 means a node connected in opposite manner. Then it go to, again, then it one command return back to 1, then it goes from 1 to 0. Then it said that 0 is traversed. But if I did not store 0 as I means if I did not reference it, then when return back in a stack, then it is not able to remember it is become I means visited or not. So you must pass the visited, and visited we just need to pass in the vectors, did not need to pass in the I means matrix I means pointing matrix like arrays in 2D arrays created. In it did not pass. It is auto reference, means there is a inside difference. If you apply reference, then it would be compilation error. After that, visited of current one means that node is passed, that is considered as visited, and see out current means this node is printed there. Any node that is currently in the stack. Let's consider this one. This one, yeah, one. Then one is printed. After that, it passed two. The same calling for two. How they see there? It called for traversing the neighbors of current means those nodes who are directly connected to current. Means those nodes who are directly connected to current, these are showing means it traversing basically its neighbors. If neighbor is not traversed, mean visited it is equal to 0, then again call for it. Go there and see it. I call for 1. 2 is visited. No, 2 is not this time visited. Go there. After that, pass to 0. 0 is visited. No, currently 0 is not visited. Then we print 0, 2, sorry, 1, 2, 0. And after that, there you know its neighbor. Then returning back to their command, and their command returning back to its own command. There could be one more thing. There, this is like something this. Then go there, and after come back to 2, go its another neighbors. See there, it said that go all the neighbor. If calling the one neighbor, then it goes inside that, then all traverse all the neighbors that are connected its neighbors and goes there in the depth. That's why it's known as the depth first search. Then returning back, then going to another its neighbors. This is the simple. This is the simple code that you tell. I mean, DFS is basically a very smaller code. You just have a good grasp on the I mean, grab down the topic of the recursion. If you know recursion, that's DFS, BFS, graph, tree, everything is become too easy for you. And the late topic is about DP. And this is simple. I mean, dry in code. And what's this space? Time complexity and space. I mean, space, no, algorithm, it is algorithm, not talk about space. If space is a, I did not consider this is a taking input space. I already passed from main function. Time complexity is B plus C means you go to every node and eventually you cover all the nodes and it edges. Then all the nodes B and it connected edges E. It is a question given there, depth first search. It could be something like go there and print something like all I mean given source and in a vector push all the nodes that are in DFS ordering and return that. Go you and practice. It could be good for you. Problem. Now we have covered all the basic things in the graph. We now need to pass our next topic. I mean, some problem solving that could enhance the topic understanding. First is the level order of trend. I mean, level node in undirected graph. It could be solved by you. I would think. I have to explain the BFS of graph. BFS of graph what? There is the same. Says that find the level of given node in an undirected graph. What of means level of a node. Let this one. This one. There is given source one, and it is undirected. So that's why I just take this one. And there is a given one source given one. Means you need to start from one and tell what is relative order of zero with respect to one. Direct one means it is directly connected. Then it's level one with respect to one. Means simple, just a difference of level. You pass this is as a source and calculate the bus as like I previously tell level, and when you pass the inside the loop, you run the loop, while loop, just while loop. I could code it for better of understanding you. Yeah, I need to pass my local ID.
Let's solve this question. The level of given node in an undirected graph. I think everyone is aware about the what's the level and the trees, and in the graph there is a similar concept has been adopted. That's saying that if asked for the level something like there is asked 3, then what of in a given node, yeah, it is a given a node, and what is the level of another node. It is if you ask for level of 2 with respect to 3, and what's that is a, if considered, then 1 2 means shortest path from that node to the given node is a level order traversal. As I discussed before, what's the level meaning things. Open the question from given the link and let's solve it. That's the this level of nodes. And this question will describe the everything that given given an integer x and undirected acyclic graph with v nodes labeled from 0 to v minus 1 and e edges, and return the level of node. Return means there is a need to return the what is the level of x is given. This is x and this is given matrix, and v is total number of the nodes is given. And there is a by default we taken from which node to which node, means from which nodes to what's the level of x. There is a by default x, and x is considered as something there like header like something, but and you could say, and there is maybe a question arises another thing that level of a given node with respect, there is something like another given like something y, and you have to find the level of x with respect to y. Then similar concept, in place of 0 you start with y. Let's start this question. We have to return the level. Then firstly level is equal to 0. After that we make visited array, then vector bool visited, total v arrays, and all are not visited, and we have to level by level. Then q, I means level order traversal q, and just wait. I think it's now everything is clear. I am saying that firstly declare a queue. Q and make Q and push the first element. What is the first element? There is a 0 is considered, and visited, and 0 is also visited considered here. These are repeated algorithm, just start changing them. After that go inside the loop while q dot size is not equal to 0, mean while some element inside the queue. Then similar like level order traversal, and find the q dot size. After that Yes, go. Its neighbors are given. Level or traversals. Yeah, similar things. Go for the all the nodes in the queue, and next or SZ I plus plus pop it out. I means store something like into node is equal to q dot front. Oh, change q dot front and q dot pop and traverse all of its neighbors. And another thing, you have to check is it our result, means current node is our target node. If x is equal to node, then return the level. If it is not, then traverse its neighbors. Similar, it's like in tree we are going for the left right. Similar in the gear there is a lot of neighbor possible. Then for what we are doing, there is adjacency matrix is given. Just passes auto made if not visited it is equal to 0, then q dot push it. And another thing, which it is visited, mark as at visited, and after exiting the loop just level plus plus, or not from this loop, actually this loop, outer loop, and return the level. It is simple saying thing of if there did not exist such a node, okay, here you need to return -1, because if node is found there, it already written there, and here is saying if node is not present, then return -1. I think everything is clear there. X, oh, small x has been taken. Yes, it is correct. Yes, yeah, this simple stuff has been covered. That if you know the level order traversal and not sending, we are making a loop that cover entire level. After that, extracting it's what the number of current element in the queue, and for that all the element that in current queue, then popping you to a sequence by sequence. And if I pop a node and that is our current node, means our target node, then return from there. And if it is not, then we are again traversing for its neighbors. This is a neighbor traversing. That's simple. Let's pass to next
Let's solve
question.
another question. That is a given that find the number of islands. There is a 2D matrix has been given, and there is element in it 0 and 1. 1 is represent island, and 0 is represent ocean. Then you have to find what are the number of islands. You did not count just number of ones. All the connected ones, means that are connected, that are considered to be a single island. When this is a single island, you can go from, means if an island is connected by it, it's a top, bottom, left, right, and it's diagonally. That is considered is a single thing. I mean, there is you considering, means there is a shown at just a wait. In this graph shown that this is its right one, and this is its down, this is its diagonal. In all its, if the node is given something like, if a node is given, then if this node is our let this one, then it's top, left, top, down, left, right, and it's all four diagonals. I mean, this diagonal, this one. If anywhere element is present, that is also counted as same part. Similarly, go for this to there, and after that it's not left, right, top, down, and there is not any connected one. So this one is a one individual element, this is individual, this is individual. Then how do you count this? We are solving the question directly. Open the question through the given link. This one I'll also open. I hope you can open. You could try it if do, that would be good. When you try, if you try, then you understand the question more enhanced manner. That if I tell the solution, that could more absorb it into you. Let's solve the question. In the question given, there is a M cross and 2D binary grid. and which represent a map 1, 0 and return the number of island. Islands surrounded by water is a form by connecting adjacent lands horizontally vertically. There is a slight change in this question and I described in that question. There we can go diagonally, but there is in this question I have described the little difficulty has been decreased. That it's saying that you only need to consider if vertical and horizontal means if this node is given means you do not consider and diagonal ones as a means island another island that is another line island did not need to go means diagonal did not need to consider. Let's solve this question. Firstly, number of island int count number means count the island number of island. After that, a 2D visited array. 2D visited array and yes, 2D visited array. Yes, is correct. Vector of bool m comma 0 and hearts the n and the grid dot size and m. Sorry, grid 0 yard. It's I just this is number of column, number of rows. I think everyone is aware about it. Next one, what I need to do? I declare this one. Then basically I am trying to do if I go traversing entire the matrix. If I go there, then if I found one, then I traverse all its connected neighbors. Means that are the one and it's connected. I visit them and mark them as a visited. If I go again, did not count it and let I skip it and pass to next one. Means if I go there, then I cover all its connected nodes. Means it's left one. It go down. I collect these two. This one also. I can go. This is right side, and after that I can cover this. This is diagonal to this. But when I go there, this is down to it. Means if any node connected to it, that is left, right, top, down. The same property again applicable recursively means if I go its neighbors then if you check it for its left right if their element present then that is also considered in the part of same island did not is any other island the same stuff so I need to make a defense function what for all visiting its neighbors that are the one means neighbors left right top down all others that are connected to it even in any way. Let's declare DFS hearts in the DFS firstly initially complete this function inside the function for and I is equal to 0 I less than n sorry and then go there of wait yes and when we need to count the number of island whenever we found a one and not visited one mean if I go there this one first element of matrix and it is visited no initially not visited and it is a one. Yes, it is one. Then count one and traverse all its connected ones. Mean go for this one right one, right, and it's also there is a nothing right, and we cannot go up because it a breaking of matrix, and also we only need to we go down and also cover it. If there are any element something like present this one, there is if also one that is considered a default because we could not go diagonally in this question. Uh, okay. Next check if visited I j if not visited it means and it is one means grid ij it is character given inside the matrix. If it is saying that if is any node that is not visited and currently if it's not visited and currently it is one then count it then just count it and DFS function what the DFS function is doing just pass grid and another thing is a visited array and another thing is a current means grid element index matlab ij row column its and another thing need to pass that is a n comma m. That's it. Go the DFS function and in the grid mark as just this thing. After that visited Yes, visited and also pass by reference. That's why all the result have been persist in it. Another thing is int I comma int j comma int n comma int m. In it, n comma h are just row and columns. Oh, I did it wrong means I did it in wrong place. I think this is correct. Yes. Next thing, go there. What we need to do if dealing initially in any recursion function, firstly deal with its base cases. What is base case? If we are traversing and something like find that node breaking means if we're going far up and that is a breaking our matrix means something like you are in the node this and you are trying to go up but there it did not any type of matrix exists and dealing with that cases. Firstly, if I is less than 0, same for j is less than 0 or I is greater than or is equal to n or j is greater than or equal to n and sorry m. And another thing, if that is a visited means if not visited that is not consider we do not need to go there because that are already counted. If that's visited I j, if not visited, and another thing we do not need to go if that is a not island, then grid uh, ij equal to 0, then just return from there. I think cover all the base cases. And now go up. What you need to go means you just decrease a row. Here I is a row, the I minus 1. Just call the DFS function grid widget I minus 1 j comma n comma m. Similarly, all other directions force you need to. This is one for up, this is one for down, off. This is one for left, and this is one for right. And in that, when you are going for current index to right index, just increase the number of column, and when you are going for left, just increase the number of, sorry, decrease the number of column, and you do not need to do anything else. After that, entering the loop, just return from there. We think is everything is good. Yes, run it. It's saying out of the loop. You have to attach this visited array because if a visited array then mark mean we do not need to go there is a, again calling call stack increasing, just to run it and submit it. Yes, that got accepted. We'll solve now next. Let's solve this question. The shortest path in unweighted graph. I think every term is clear. What is shortest path and what is unweighted graph? Mean all the edges weight is a constant. Means same weight is a more precise word. The given an unweighted graph and source and destination, we need to find the shortest path from the source to destination in the graph. Let's open the question and solve directly from there. Open the question through the given link. This is the question. It is saying that you have an adjacency list and in under curve there is a unit weight is assigned to everyone and find the shortest path from source to all other indexes. Mean if there is a source given, there is a source given is like 0, mean you have to find the distance from 0 to all other nodes. If all other nodes and all the edges weight mean distance from any node to just its consecutive nodes is just 1 unit. And if the array did not exist any path, then return the -1. In this question, we are again applying same concept, that is a level order traversal. Means if this is a graph, mean if any node I achieved from this node that I considered as the shortest distance, Means if any node that is covered from this node firstly, mean that is level already covered, that is the shortest distance, the simple concept. So again need to same thing, level order traversal. Just their simple thing. You need to return a distance from that node. So first you declare a distance node, means that contain distance. Then there are how many nodes? Adjacency matrix is given. So n is equal to adjoint dot size n nodes again, and all distance are initially -1. And another thing, we have to make a visited array. So vector bool visited and all are initially non-visited, and make a queue to level order traversal int queue and push queue first element what is source. There is some may be 0 or may not be 0 source again. Something like there would be just pass a change. This is source. Make it variable. After that, if I push in the queue, then mark source as a visited. Then visited source as 1. And another thing, distance from source to source is 0. Means if anywhere distance from 0 to 0 or 3 to 3 is very general word is 0. Then it's variable 0. After that, simple pass in the loop. If q dot size is not equal to 0, then pop the front node. Firstly, store the front node and pop it out. Oh, sorry. Yeah, there should be front. After that, traverse all its neighbors. Adjacency matrix node. And if any node is not visited, if visited it is 0, then distance of it is equal to 1 plus distance of node. How I am doing that, I will tell just a bit. Visited it is equal to 1. After doing this, come out and return the distance array. It is saying that if you are go from like 0 is sources again, you go from 3 in the next level, you are 3, and after that 4. So hard distance 1 2 2 unit, and it's saying that if you are at 2 and you are covering something like its neighbors, if not covered, 3 is already covered, so did not anything about it. But when you are come to 5, then hard saying that it is equal to 5 and node is 4, then it's saying that if 5 is not wasted, yes 5 is not wasted, and distance of 5 is equal to 1 plus distance of node, means distance of 0 to 4 plus 1. It is simple. I think everyone has got it. uh, Everything is clear in it. Just run it. -1 not visited. Okay, uh, push in the queue. Yes. Yes, it is correct. So you can understand from the code and the given description. I think question is very clear to everyone. Let's solve next question. Here is another question again. Shortest path in unweighted graph. You have to find the shortest path in unweighted graph. I hope the meaning of unweighted graph is very clear. It's the weight is a weight is a constant in overall the graph. You can open the question through the given link. Not there. Okay. Yes. Let firstly I tell about the question. It will be even. There is a question saying that you have given some node like this is source. This is source node. When you are starting from here, it is something like you are Pata junction or something like that, and you have to find the shortest distance from all the other nodes that are connected to this. Then you have to do simple BFS traversal. So the BFS traversal, you find all the nodes distance. Means if when you are going from this node, then these both nodes are the same level with respect to 3. Mean you go 1 unit, then also find 0. You go 1 unit, you also find 4. means they are at the same level. Then both are distance 1 unit. Then we assign 1 unit to this. Again, when we go from 0 to 1, 0 to 1, we already stored the distance from 1 to 0 as 1 unit. Then when we are going to from this unit, we already adding this already stored number plus 1. What is already stored number? 1 plus 1. Mean this is 2 unit distance. Again, when we are going from 2, we already know that this node to this node. This is the hard distance. This is 3. Means already stored 2 and 1. And similarly, I go from this node to this node. This node is what? This is a 1. And when this I go from there, this is 2 and this is 3. After that, I go from here, this is 4, this is 4. This we need to return a 1D matrix which store the distance of the all other nodes from the 3. I hope question is clear to everyone. Let's understand how we decode it. Firstly, if it is saying that you need to vector, say let's declare a vector. Vector it's something like answer and distance from that node to every node get initially considered as -1. You could take any there is a saying there's -1 also. Yes, -1 that is a perfect. Means if node is not reachable, that written -1. Means there are something like how many nodes adjoint is given and how adjoint is given. Okay, it is given node by node. I mean it's eventually a matrix. I would make it a adjoint adjacency matrix that would be more beneficial for us. Something name change something like array. Firstly make adjoint matrix and how many element in int n is equal to ar dot size. It's not representing like 1 2 3 4 5 6 7. Yeah, it is same number of nodes. Extract from there. Yes, it is good. I am making adjacency matrix and you will also learn how to make adjacency matrix from a given matrix. I mean this is matrix, how would make adjacency matrix? Firstly declare something like a vector and an adjacency of an array and how many element? There should be an element. After that, and traverse this given matrix or int I is equal to 0 and I less than ar dot size I plus plus. After that, go there and this is the number of columns. That's good. After that, yeah, we need to make adjacency of firstly declare int u. What's int u? And we did not need to 2D like something. We can do in singly because in 1D, every I mean every row has only 2 elements. So int u is equal to ar of 0, comma b is equal to ar of 1. And what's it is this? Yeah. After that, marking adjoint of v dot it spec u. Similarly, we already successfully made this is how you can make adjacency matrix from the given matrix. After that, make another something like visited array. There you need to just make 1D visited array something like all are initially non-visited and mark source as visited because we need to push it. Yes, mark source as visited. Another thing, make a queue to be we are doing BFS order traversal as I did discuss and alternate int q and q dot be push source something like just like a root means head similarly pushing the source. Here is source given and another vector I need the answer vector that is a distance from means source to all other. Initially we did not know, then mark all things as -1 and another distance from node to node means source to source is 0 and current to current is by default 0. It's simple thing. Okay, after that we are doing the BFS traversal while q dot size is not equal to 0. Wait, yes. After that, what could go for its neighbors. Firstly, int q dot pop it out, मतलब front node, something like node is equal to q dot front and q dot pop. Here you did not need to maintain another for loop by level order reversal. Means that you need to present something like it do not need to extract both 0 and 4 means in the same time. You can go one after one. Then for its means is we are covering our neighbors of source. Then auto address of IT. Auto is just auto detection of data type. Another thing that we are doing adjoint of what node. If Visited of IT is equal to 0 means if node is not visited, then mark node as visited. And another thing we can need to do, node dot push it in the our queue. Yes, and the main thing you need to do, and distance of u is equal to, sorry, distance of IT is equal to 1 plus distance of node. Means what are reading? We saying that if you are searching like something like 2, if you are the current node is 2 and you are, and 2 is neighbor of 1, then when we are at 1, it's searching for also means when running a loop, then it is 2 is present. How could I tell? I hope the density matrix is very clear to everyone. Density matrix stores something like first element, what's its neighbors. Yes, when we are adjoint 2 and something like written something like this, something like this adjoint of 2. Then it's a matrix that store its neighbors. What is neighbor? 6 comma 1. Yes, this is adjoint. Then when we are at 2, when we are at 2, then what are we doing? We are doing simple like when we are at 2, then go for 6. There 6 its neighbor are searching. Then let 6 is not wasted. Okay, not wasted. Mark it is 1. Push in QQ. And what distance from 6 to source? That is the distance from source to 2 plus 1. Similarly, same thing going. What is IT? IT. Here is IT value 6. IT is 6. Then IT's distance of 6 is equal to 1 plus distance of node. What is node? What is node equal to 2? I think this is clear. After that, just return our answer array. Let's run. Wait, how React after what's doing it? Somehow time did it. Wasted watch. Wait. Yes. There is a mistake. There is a given a matrix and it's saying that it is adjacency list. Why it is conflicting? In the image is given that it is a matrix. I think it is already given adjacency list. Then comment it out. Declare it as adjoint. Yes. I think they updated the question. Then image is not updating and text had been updated. Yes, it got accepted. Means there is a question something like there would be different, but there is a matrix given in the image. So I thought that it is a matrix, but it directly adjoint matrix is given. Now this question has been completed.